In the world of pop, it's hard to find an original talent, but here is one, a man who is writing and singing some of the best songs around at the moment. With his latest, Where Do You Go To, My Lovely? Peter Sarstedt.
You talk like Marlene and Dietrich, and you dance like Zizi Jamais. Your clothes are all made by Balmain, and there's diamonds and pearls.
Good evening. This is my talk about Where Do You Go, My Lovely Freight Train. And what's it about? Well, I'd started off thinking about trying to do quite a technical talk. And I thought, having looked at the intent of the Sheffield Digital Festival, having looked at the intent and the kind of challenges, that maybe I should start looking at a slightly broader topic, and then probably ended up in a bit of a rabbit hole. So here we are. I've come to talk to you about the timetable and why the timetable is awesome. And so here we have. So a couple of years ago, because I do some work in the European Railway, and a colleague of mine called Milos Vitera, who works at on the Czech railways, sent me a copy of the railway, sorry, the play Rossum's Universal Robots. It's interesting. It premiered in 1921, and is actually where we get the word from robot, and it introduces the language. And in this there's this magnificent line: Madam Helena, the timetable is the most perfect product with human mind. And if you ever work in the railway, that's clearly true. It talks about androids, and then obviously has a terrible end when they throw off their human overlords and destroy the planet. But anyway, that's hopefully not where we're going to get to, although there's an element of destroying the planet that will come through as a theme throughout this talk tonight. So, but it's all Greek to me. So here is the start of the Iliad. Goddess, sing to me the rage of Achilles, Peleus' song, whose anger brought countless sorrows on the Greeks, so many valiant souls of warriors to Hades, leaving their bodies to spoil for dogs and crows. There you go. I thought I'd kind of start off with a nice upbeat note. Anyway, so this is a nerd adjacent view of the preparation of the timetable. I'm Will Deakin. I work in the UK rail industry. I work for Network Rail. However, this is me in my personal capacity. If you want to follow me, there's my Twitter handle. So this is part of the Digital Festival. I'm trying to make it a bit Sheffield related, although it's probably more about national and European railway. And on that basis, I'll just introduce myself. Not everything I say is true. I work in the IT world, so I don't really have a great deal of experience of operations other than through my role. And however, in paean to the great city of Sheffield, I have tried to include some pictures of Sheffield as I go through. So welcome all. So there you go. What's it all about? So what we're talking about is the key aspects of the railway. So it's about planning. So to run a railway, you have to plan, you need to prepare your trains, you need to run your trains. And in freight, you've also got to look at your wagons. So tonight is going to talk about this bit. And this bit is all about the timetable. So the timetable in the British Railway is based around the wonderful, wonderful common interface file, which looks like this over here. It's an 80 character fixed format fielded interestingness, and one of the things I'd like to touch on is why it's not great. A lot of the restrictions we currently have in the railway, and I'll touch on this a little bit later, are the fact that certainly more generally in the railway, more specifically in freight, we have a lot of very old systems that run in a way that probably need to be addressed. So here's train preparation. Is it about that? Is it train operations? Nope. It's not about this either. So we're not going to talk about traffic management tonight. And we're not going to talk about this. So this is the control center of the future. If you go to any operations piece, this is what you see, CCF. This is how people run this. So this is where you'd look at a live sheet. So what are we talking about? And then you kind of go, why rail freight? So here's one of my pictures of Sheffield. So I think for me, it's not loved enough. I think it's a really important sector. I think it's something that could make a massive difference to and benefit this country and more internationally, but we don't really treat it very well. And I think what I wanted to do was to kind of highlight some of the things that we could do about that. I think it has quite an important impact. And so part of the theme of the festival this year is around the idea of sustainability and what we can do to make things a little bit better. And I'll try and touch on that a little bit. So first, so there you go. Climate change, environmental damage, UK rail modal shift. We've got to do no net emissions by 2050, economic growth decoupled from resource use, no person and place is left behind. So this is the kind of thing that we signed up to a few years ago, although this is probably more of a European view than the one that's currently present in the UK. So in UK, rail freight. So if we look at freight, 77% of it by ton kilometre, which is the standard metric. So these are the last figures that we've got. 70% of that's by road, 14% of it is by water. But I think part of that's also down to the fact that we do transport a lot of stuff between the mainland of Great Britain and Northern Ireland, and that goes by boats. Although there's actually quite a lot of heavy stuff that seems to go around coastal or even inland. Then finally, you're left with this 9%. There was a peak, so that's 15.9 billion ton kilometres, which is the, as I said, that's down from 22.7 billion ton kilometres in 2012, 2013. But that's where there was a lot of coal going to power stations. And as you can imagine, that's not necessarily where we want to be. So greenhouse gases. So the UK produced 45 million tonnes. Again, not brilliant, of which 26.8% is transport. Most of the other sectors, if you look at the figures for this, actually have declined. Transport is stubbornly constant. So 16% of that was HGV. So that's 4% of the total. And all rail was about 1.4% or 0.004% of the total. And then the other factoid I want you to take away is that one freight train removes up to 76 HGVs off the roads. And we'll come back to that again in a minute. So comparisons, there you go. If you look at cargo ships, if you then look at rail. So I'm going to try and highlight this particular fact. So we're looking at rail. So you can see a freight train, and this is based on diesel and electric. And what you actually see here is that when it compared to road, 50%, 100% loading, rail is actually a much more effective way of moving goods around the country. So that's the kind of introduction. And I've just kind of set out the stall. It's going to be about green issues. It's going to be about why we need to kind of force modal shift to actually get us to a position where we can actually move more of the goods on track and get it off the backs of trucks. So when we plan, what we need to do is there kind of a whole series of things. So if you kind of sit and talk to people about planning, dependent on where they sit in the organisation, you get a different answer. So the timetable is something that touches across all these different areas. And so the people you're talking about are strategic planners. They want to know where do you want to invest. So they've got quite a long-term view. So they've got 3, 4, 5 out to 15 years out. And they want to know where you can get the biggest benefits. We're not really going to talk much about that. Then you've got the access planners. They're the ones who take the output of the strategic planning process and then try and turn it into things where we put new track or fix the track that we've got or replace the signals. So their job is actually weirdly to take things away from the timetable, but to mean that the timetable runs better. Then we've got what we would normally call timetable planning. And there are kind of two parts to this, and we'll talk about that a little bit more. So we've got a piece around timetable planning, which is the request from the operator. So I want to run some freight. So I've got to try and bid in. And my idea here is that I want to be able to run some services. And then you've got a get that goes with that, which is the network rail view, which is that I want to plan a conflict-free timetable, which gets the most available from the capacity that's out there. Then I've got assessment. I've also, and this is a particular issue for freight, got to make sure that those trains that I'm running don't conflict with each other, but also don't conflict with the infrastructure. And because of some of the nature of what we've got in the railways in Britain, and I'm sure people like Liam, who's on the call today, will know more about that than I do. There's a whole piece that needs to be done on it. Then we hand it across into operations. So they manage a working timetable. We won't have a lot to say about that. And then after the fact, we've got the performance teams who take a score and make sure that find out what went right and what went wrong. So a more detailed drill down. So there you go. Here's the whole of the key railway processes on a map. You've got some stuff across the bottom in dark green, which is about what the railway operators and the rolling stock companies have to do. They're the ones that have to take the demand. You've then got the dark green pieces, which are the planning function. It's called System Operating Network Rail. You've then got the routes and the operations teams who actually do the maintenance of the infrastructure and actually deal with the running of the trains. And then you have the performance team who we've mentioned. And to make all of this work, we need to have a logical infrastructure model. So the railway in the timetable is based on a kind of an abstracted view of the railway. People don't use actual maps, they use an infrastructure model. And then on top of that, you've got to be able to layer capabilities. And we'll talk a little bit about the kind of capability to replay that. So timetable development. So this is the first part. So how is the timetable developed? It works in two kind of time lenses. There's a long-term planning view and there's a short-term planning view. This first part, we'll talk about the long-term planning view. So about 72 weeks out, the access planning teams start looking at what they want to dig up. So they've got their strategic views. So they're looking about 18 months out, and they're going to start planning in that work. And as part of that, quite a lot of the movement of material to support access and engineering works runs on the railways as well. So there's a chunk of the freight sector that is actually just to keep the railways running. You then have about 60 weeks out, the train and freight operating companies want to start giving freight notice. So if they've got a regular pattern of movement, they start need to tell the planning teams and think about what that needs to look like. And then we move to the 42 weeks out. This is when the formal process, the request for bids to go into the long-term timetable starts. And then about 26 weeks out, Network Rail starts to publish its base plan, and then everything after that. So that's a whole stack of work's gone into that, but that 26-week point is really quite important because that's the point at which the overall process starts that probably is more affected to the freight world. So what is planning actually about? So here you go. What you're trying to do, and this is a kind of quite an advanced system, and it's based on the only example I could find is actually based around the Swiss railway. Here you've got two trains running in parallel, and what you try and do is that you break the track up into a series of fixed blocks, and you try and work out when those two trains start to become close to each other. So the whole point about it, and we won't talk much more about this, but it's about trying to resolve conflict so you get the most out of the network. And a lot of what actually happens in the timetable planning process is about trying to balance the give and the get and the different characteristics of that. So what you have is a speed profile for the train. You then look at where it needs to stop and start. And then on the basis of that, you start looking at how it's moving. So you can see here a kind of a distance time graph. And a lot of what a planners do is based around this. So we're talking about long-term plans. So there's a particular part of the process, which again is quite critical for freight, which is called VSTP, or very short-term plan requests. As you can see here, there's a whole stack of information that needs to be provided. And this is where you start getting at the pointy end. So this is kind of looking at a week or two, or even out to, there's a process called day A for C. So day A for C is where if I make a request by 5 o'clock on a Monday, starting at midnight on Wednesday, I can actually start running a train anytime in the following 24 hours. And then finally, the output of this is this wonderful fixed file format specified in the common interface file. And we probably need to do something about that, and soon. And then finally, there's a whole special pane to do with trying to decode the CIF file. There's a kind of a 5-page document about layering and compounding of schedules. So the way that you work is you start with a base plan and you put something on top of it, and you might cancel that, and then it's very complicated. I'm really going to advocate at some point for coming up with a where is my train service rather than trying to fix this. And then finally, there are a whole series of systems. So these are the systems we've got. The youngest of this was put in the 1980s. Some of them were actually put in the 1970s. And a lot of the systems, so there's a system that is what is my train, which is about the consist or the units to go and make up a freight train. is actually based on a mainframe system that was developed in the 1960s. It's called TOPS, and we really need to start thinking about doing something about that. So there is some work we've been looking at trying to come up with a mainframe roadmap to try and move away from that, but it's hard. There's a lot of processes and history that goes into that, and it does quite a good job, but I think it's starting to become a barrier to what we need to do moving into the future. And then finally, so there you go. I don't know if this bear, but he's apparently quite famous. So what we're going to do is, so we kind of talked a little bit about the kind of aspects of the timetable planning, and now we're going to look at how a freight operator starts looking at their timetable planning. So again, we're now looking at this kind of point on the so that's the bottom right hand corner there, and again we're talking about the dark green sections here. So we're talking very much about the timetable planning system and how the freight operating company has to kind of align access to track so they can run a service, but they also need to make sure that they've got the right stock available, the characteristics of the stock matches the route that they're going to be offered. They've got to be able to make sure that they've got the locomotive and the wagons available, and they've also got to be able to do crew planning. And the current systems, so here's something that's been taken from the concept of operations for crew and stock planning produced by the Rail Development Group. You can see that there's a kind of idea of where you've got to take the timetable in, and you have fleet systems, because a lot of locomotives aren't owned by operators, they're actually rented out. And what you then have to do is you've got to look at the planning and resource management and then the control part. And then on the day operations seem to be fed, and then also railway industry systems. So people need to know, actually, is the train ready to go, and is it ready to depart, and are signallers aware of what's going on? And as part of that, this is currently what a stock diagram looks like. It looks a bit like, it's kind of not great, but as you can see, it tells you in a fairly arcane way the different pieces of work that the train starting Victoria and going up and down to Dover and back is operating. It gives you an idea about how but it's kind of difficult to kind of get your head round. So there needs to be some thoughts about how we can actually improve this. So you can also see things like there's a four character head code buried in there. So the 5SO4 is actually a non-unique identifier for the train, which again is a problem. And then you have associated with that a crew diagram. So this kind of tells you what the driver's planning to do. And it doesn't necessarily, you can see there's are significant differences, and it is really quite difficult to understand. So having put in your requests, having sorted out what you need to do around your resource planning and around your stock, and apologies, I can't see messages, so you might need to just shout if you need to get hold of me. So what we've got to do is we've got to a point where we're now looking at the process by which we've got a base plan. We now want to make a request for a bid for a path. So the next part we need to do is Network Rail timetable assessment and allocation of that. So the idea is that having gone to requesting something, the Network Rail team then need to look at, is there capacity available, and actually try and start looking and working with the operator, the freight operating company, to make sure that that train is actually safe to operate. And that in itself is not an inconsiderable task. So again, so we're now starting looking at these lighter green sections around timetable planning and assessment, and then moving into the train publication. And based on, so we've kind of got lines 1 and 2, which is the bid offer process. Having completed the bid offer process, we then, as part of that, got to make sure that there isn't any conflicts. You don't want two trains running into each other, or as we saw with that diagram where you could see the potential conflicts. We then need to make sure that there are a whole series of other things that line up to make sure the train's safe to run. So the team within Network Rail that run this is the National Planning Team. They're broken into 6 different groups, and they have a number of different responsibilities. So we have the Network Services Team, who look after STP requests for short-term planning requests, but specifically to do with the maintenance work. So where you've got monitoring trains, where you've got seasonal, so you've got path clearance, or cutting down bushes, or actually the engineering haulage. You then have the A4C team, which I've mentioned before. So this is part of the short-term planning process. They look at day A for C. So this is the very short-term plan. So somebody's phoned up and said, I've got 15 containers I need to get from Felixstowe to Doncaster. Can you help? And it's their job to see if they can thread that through. And typically they deal with 1,200 requests for freight every week. We have the informed traveller. So informed traveller is about having done the access planning work. You've got to be in a position where, and I mean, informed traveller is probably more to do with the sale of tickets, but it also applies to freight. So this is where trains are rerouted, where the engineering work or the need to have access to the network is finally sorted out. And so there's a final check at 12 weeks out that is used to ensure that there are no conflicts with possessions. We then have charters. They deal with the steam engine world or the holiday world, or let's go for a football match. So they deal with kind of the spot bids around those particular pieces of work. We then also have the rolling spot bids, which is a way of actually requesting. So there's a kind of a process where you can get potentially a discount on the movement if you're prepared to wait for capacity to be freed up. And then finally, there's the team that deals with the freight planning performance, where they actually look at how did it go. And this being the British Railways, we have a whole series of adversarial processes based around the 1993 Railway Act. And so if you ever hear anybody talk about this, they might talk about Schedule 4 payments, which are to do with payments related to having passed taken away. So access to the track taken away based on possessions and engineering work, or on the fact that something went wrong. So there was a failure. And if it's Network Rail's fault, there's a thing called Schedule 8. But also, if you were the core, so it was your locomotive that failed, there's an expectation that you'll pay others. So it's not great. And we'll talk about it a little bit later, because it's one of the things that the Greater British Railways is looking at trying to address. So we're now going to start talking a little bit about short-term planning. So a little short-term planning, we've kind of touched on the fact that short-term planning is around this 12 weeks down to the start. So the first thing about it is we've got 12 weeks, which is when we've kind of firmed up the timetable. We should now know all of the planned engineering work, so we actually know what capacity we've got available. So you can actually then put in a request for a spot bid. The next part about it is that you can then also ask for day A for C. I've already mentioned this. I haven't quite remembered which order I was going to give you this talk, so there you go. And this is this idea that you can make a request on Monday by 5 o'clock, and then you should be offered up that path. Post day A for C, there is another process. We've then got, which is the VSTP. Once you've actually missed that, by prior agreement, it is possible to have the planning team put in a day A for B. So if you know that there's going to be a load of disruption, or there's going to be something you need to sort out, you can actually get some planners on tap who will actually rearrange that. It depends where you are on the network and if people are available to do that, but the standard process is actually based around day A for C. And then you can actually, and this is where it gets a little bit murky. So in the operations space, the timetable's handed over, as I've said, by, so the timetable's closed from the planning department at 5 o'clock. Having planned that, it's then published by about 1 or 2 o'clock in the morning and handed across on the Tuesday to the operations team for uploading. And because the operations teams are based in different routes, they each take control of their own operational area. It is then possible to do a very short-term path, but the issue with this is that rather than it being a national function, you've kind of got to coordinate it with the different operations team. And this is a particular issue for freight. So if you were operating a kind of high frequency service around London or Manchester, it would be relatively straightforward because you're just dealing with one particular route or region within Network Rail. If you're moving freight, you've got to start then having conversations. So if you're trying to move something, I don't know, from Penzance up to Edinburgh, as you can imagine, you've got a whole stack of more people to deal with it. And there's also another issue with this, which is VSTP, very short-term planning, is actually used in two senses. So there's actually VSTP, which is the operational process prior to the day of departure. And then there are actually processes to do with operations. So if you need to cancel and create a new train service, that is also called VSTP. And one of the issues I've got with this is it actually causes confusion, because quite often I'll be in discussions with people and I'm going, well, it's a VSTP. And I kind of go, are you trying to change the timetable the day before? Or are you actually trying to change the timetable on the actual day? Because the impact is quite different and the kind of checking you need to do is quite different. There was a story, again, based on the European Railway a little while ago. So I've kind of put this in context and why it can be important. When Pope John Paul II died, there was a need for quite a lot of people in Poland to travel to Italy via Austria. And a colleague of mine, and I'm struggling what his name was, I'll call him Stefan. A lot of my German colleagues are called Stefan, was actually asked what's going on, because they'd cleared all the paths out of Poland and got them into Austria, but they seemed to be stuck on the border. And they were kind of going, well, have you talked to the Italians? And they're going, yeah, we keep phoning them up and they say there's nothing they can do for us. And then Stefan went, well, that's because the funeral's next week. You shouldn't be talking to the planning department a week out in Italy. Didn't you know you should be talking to the operations team a week out? And so the kind of understanding the different time windows and actually how they change between different parts of organizations, and certainly on international, is really important. So if you want, as I discovered, if you want to do an STP path in Poland or Austria, it runs to about 72 or 48 hours out of departure. If you want to do one for a train that runs to Italy, I'm afraid you've got to start thinking at least a week in advance. Otherwise, you've got to talk to a different department. Anyway, moving on. So just in terms of that, so the VSTP, the second part is actually around this kind of idea. So we could talk about this a little bit. So where operations starts is the handover about the compare current plan. So I said we wouldn't talk about this, but I'll just talk about it for a minute. This box on the top left-hand side. And then where the VSTP comes in here is on the day, is when you're actually planning recover services. So you've worked out that you've got to glue two services together, everything else has been cancelled. So what you'll do is you'll create a new train service, and that again is called a VSTP. Anyway, I'll stop labouring that point. What have we got now? Timetable assessment. So timetable assessment is probably the darkest art when it actually comes down to the joy that is freight planning. There are people here who know far more about this than me, but I will literally try. So the first thing you need to do is you need to have a logical network model. Here's one that's based around the kind of control center of the future, but you can kind of see here's rugby and you've got different positions. And what you're trying to do is, rather than trying to represent it on a geographical map, you're trying to abstract this. This, I think, is from Open Train Times. But there's also another abstraction that's quite often used, which is the thing called the sectional appendix, which is now the electronic sectional appendix, which again is a problem. And here you go. This is how, in the world of access planning and the asset world, so the world that looks at the physical infrastructure, this is how they look at things. So in here you can see a number of things. You can see numbers on the lines. They've got names, which are not unique. Sorry, they are unique, but they are not commonly used across all systems. So there's a data problem there. You've got speed, so you have a permitted line speed, and you then have a whole series of other information. So this is the platforms and direction of travel and some other stuff. And then you notice that you've got a series of figures on the top. So you've got line of route, and then in the middle you've got a thing called the engineering line reference, or ELR. And then on top of that you've got distances from a 0 point. And this is actually quite important, because this is quite often how, because of the linear nature of the railway, information is communicated. And trying to link this to a planning map or trying to link this to a geographical map is actually one of these sort of deeply unsolved data and business problems within the railway. So infrastructure constraints. So can you see here that you've actually got a painted on marker? This is telling me that bridge 656B, which sits above Sheffield Station, just is at 158 miles and 24 change. So moving on, loading gauge. There you go. What's loading gauge? So one of the constraints, which is the bane of freight's life, is so you have the sectional appendix, which is a diagrammatic view of running lines, And within this, it gives you the information I've described. One of the points that's actually quite important when you look at the line speed, during the discussions a little while ago, there was a rather unfortunate incident following flooding where there was a fatality in Carmont in Scotland. And one of the points that was made was that the train driver was driving very close to the speed limit. And that's actually a misunderstanding, because in the railway, you are expected to run at the speed limit. So it's not really a speed limit, it's a permitted line speed. So a kind of this view that you're driving at 30 miles an hour and then you slow down, actually a lot of the training and a lot of the work that goes on in the way that people operate the railways and what a lot of the drivers have to do is about making sure they are running at the speed that they are safe to run at. If you start trying to slow down, you start running up with a very, very inefficient and poorly behaving network. So I just thought I'd mention that. Where that becomes a little bit interesting is you can then also, to support engineering work, or if there's actually something like heavy rain, you might then need to run at a temporary or an emergency speed restriction. But yes, so drivers are expected to drive always at the speed limit, not at taking a decision. So anyway, moving back to loading gauge. So loading gauge is a kind of idea of the maximum height and weight that you can actually fit down. And whereas passenger trains, you tend to have sorted those out and they tend to be fairly fixed. What you find with freight trains is they come in all shapes and sizes. And this particularly comes in when you start looking at, so you can see here a diagram. I was trying to find a nice picture. This was about the best one to come up with. So on the top, you can see Eurotunnel, then got the Russian gauge, then moving down. And then you start looking at, can you see in the bottom, there's a thing called W6. So W6 is quite a common British gauging. And as soon as you start trying to run freight through that, guess what? You end up with nasty marks on the top of your tunnel, which isn't good for the freight and it's not good for the train. And people are unhappy. So one of the things you actually need to do is to look at making sure that when you're moving, you've got to enable them to have maximum height and width for railway vehicles. And one of the things that's actually quite important about this is that things like if the track bends or if you're moving faster and so the train's wobbling more, you can also start being able to impact the size of the hole you need to go down. So again, so here you go. Here's the sectional appendix for Sheffield. So you can see, as I mentioned, the kind of idea of the permitted line speed. This particular piece only gives you information about, and then if you've got passengers or you've got loops, it will give you some information about how long the train can be. And then you've got another set of tables in there, which are the route availability. So route availability is to do with axle weight and gives you an indication about how heavy the train can be. And again, you can see these ideas. You've got the loan of route, you've got the engineering line reference, you've got from and to, and then it tells you about based on the class of train. So these are different train classes, which I would humbly suggest is not the best way to do this, but it's the way in which the railway operates, and I think maybe we need to think a little bit about that. So I'm now going to tell you about why I hate the sectional appendix. All right, lots and lots of the data in the railway, and this is a shocked nymph sitting statue. It's published as PDF. Some of that PDF is pictures, some of that PDF is in tables. It makes it very difficult to build IT systems. I've done some work, I've talked about it elsewhere, trying to take some of these tables, certainly these tables, and turn them into something that you can get in a spreadsheet, because a PDF doesn't cut it. Here's my rant about why PDF is evil. I'll put that up there for about 5 seconds. It's hard to grovel through the PDF tables because they're being produced by people and they just don't work. If you're trying to do IT, it makes your life impossible. Anyway, enough already. So we've talked a little bit about the different planning aspects. We've kind of gone through the section appendix. It's not electronic in a way that I would expect it, other than it being PDF. There are also other pieces of document that we have that produce in that way. We have weekly operating notices and engineering exercises. There's lots of stuff. It would be so much better if we could actually get it into even into a table or a spreadsheet. So this is a particular point. So we kind of covered off the different parts, starting with strategic planning through planning and engineering work, the timetable planning process from the freight operating company, from the Network Rail side. We've got the assessment piece about making sure the gauging, the availability and the speed will mean that you can run, that you've got capacity to run that. And then this gets handed over to operations and performance. So there you go. Here endeth the first lesson. So the next part of the talk, and if you're still awake, is about how should we plan. So what is it that we actually want to see from a good timetable? So my thought is, where do you want your goods to go? So where is that? Is that where people are? Is that where railway is? Do you want to change the behaviour? So we've got this massive challenge around the availability. Sorry, we have this massive challenge about trying to decarbonise the transport network. And what do we do? Do we look at where goods are currently moving? Do we want to look at where the roads are? Because clearly 77% of all the stuff's moving on roads. Is that a sensible way to work? And what are the problems? What are the barriers to actually getting freight to work? So are there places we need a new railway? So this second half of the talk is going to be a little bit kind of exploring some of these themes. So here's some work that I did a while ago based on trying to look at passenger time chloroplast. So chloroplast is a kind of coloured indication of where something is. So you kind of get time from Sheffield based on the number of minutes it takes to get, and you can kind of see where the railway tracks are or where the fast lines are. And this was based on Office of National Statistics. As far as I can see, we don't have that data available to start being able to do this kind of analysis of the railway. So again, an approach, if I was going to start, and this is something as a side project, there's kind of a discussion going on around a Network 2050 about what would a good railway network look like in the year 2050, where we're meant to be from net zero. And if you look at where people are now, and you look at projections of where people are going to want to live, there's a kind of idea that you can look at where the current stations are, you can look at population density, you can look for gaps. There's a lot of stuff there, but it just doesn't seem to exist in quite the same way, possibly because it's commercially sensitive, possibly because of the way that people think about freight. It doesn't seem to have the same level of focus or interest to kind of deal with trying to look at what a strategic freight network looks like. I've done some more work in the back end of this to look at what's available, but this is where it becomes harder. So again, if I was going to start with passenger travel, I've got census information I can look at. So the census also asks people how they get to work. Obviously, the 2021 census is going to be a bit interesting, but based on the 2011 one, you get a whole plethora of information about public transport versus active transport versus. So this is actually based on a thing called the middle super output area, and this kind of the numbers based on travelling within that middle super output area for Sheffield. And then there's also statistics published around travelling between areas. So there you go. This is the kind of figures that people were quoting back in 2011 for transport between Rotherham and Sheffield. There again, I produced some maps. It's on the web. I can provide the links to that. And I did a previous talk a little bit about how we pulled that together. But again, I don't know how we could model that for freight, because there just seems to be this huge gap missing for this kind of information. So how are we going to go about building a strategic railway? There you go. There's the golden statue of victory in Berlin, or as the locals call it, Golden Elsie. So let's start off with what the big people had to say. So Great British Railways, William Shapp's 2021 plan for a railway. It says, Britain's railways can and will spearhead the nation's ambition to become a world leader in clean, green transport. Decarbonisation, greater biodiversity, improvements in air qualities in towns and cities will ensure rail is the backbone of a cleaner, greener public transport network. And one of the areas they identified is the fact that it's so complicated. Look at that. This is what you've got in the current industry structures. The rail freight market, has transformed, as we mentioned before, from moving away from carrying coal. It lost about 25 to 30% of the overall load, but it's now moving much more construction and container goods. So one of the key areas that needs to be focused on is the ability to carry container goods. I remember having a conversation with some quite senior people at one of the large freight companies, and I asked, because the European model is very much more about either doing whole freight loads or intermodal mixed container loads, and they said there's no money in containers. And yet, I mean, I've not been in the rail industry that long, and yet 5 years later, we're in a position where actually we're seeing a significant shift towards that. And we'll talk about that a little bit more in a minute. So there you go. This is the new simplified railway with the Great British Railway sitting in the middle. The problem with it, as I see it, is when's it going to happen? When's all said and done? Far more seems to have been said than done. So anyway, the key strategic work that's called out in the William Shapps report seems to be being rowed back on. We seem to be having a kind of lack of focus to actually do this. And I am concerned, as you'll see, that we aren't actually going to land in a position where we're going to be able to hit these kind of 2030 or 2050 targets. And just having a plan that should be in place in 2 years, but looks like it's going to happen in 5 years, is not really going to make the modal shift that we need to achieve. So one of the things that's really important about this is rail electrification. So we're going to talk a little bit now about some of the stuff, some of the boring stuff around how you might actually move towards making things better. So electric has the advantage that you can make it carbon free. Once you put it in, you can actually get renewable electricity, and on that basis, you can actually deliver a zero carbon network. Actually, network freight is very efficient. Even with diesel, the friction is very low, but there are some issues with that, which I'll talk about in a minute. So one of the things that I've been involved in is this point. So Gary Keener, quite an interesting chap, does a lot of work in actually building fizzy knitting, as he calls it, came up with an idea, and I was one of the usual suspects here, where he had a call out for trying to build a network map. And so we did. So one of the areas, so I was talking about the lack of data. Well, there is some data here. There is rail electrification data based on the OpenStreetMap. You can actually look at this, pull out the tags, and draw a picture. It would be interesting if we could do a similar piece around gauging information or route availability, or actually trying to make some of the challenges, because as you'll see, there are already issues with the network. But again, the data seems to be buried in PDF files. So one of the other things that came out from this, can you see? I mean, I've just trying to pull this out, but can you see here is Felixstowe? It's quite a big port. Oh, look over here. Here's Peterborough. If you look, I can't get from Peterborough to Felixstowe under wires. I've got to have a diesel engine. And there's this slightly interesting kink is here outside of Ipswich. So there are kind of significant issues around the issue with the network. Only 35% of the 16,000 kilometers of track are actually electrified. This is one of the lowest in the whole of Europe. There's a report, the Network Rail Traction Decarbonization report, and estimates that actually 85% of the network is suitable. But the point about it is, when's it going to happen, and how do you go about that? So I think the first thing I would commend is that where you've got these relatively small sections, why don't you just do the infill network? Because that would actually, because obviously with electrification, you've got to be in a position where you've got the whole of the route under wires. So the William Shapps report even calls us out. This will be accelerated to help improve freight connectivity through interchange and create better links with free ports and clean, greener rail freight journeys. Wonderful words. Words don't butter any parsnips. So data access. This again goes back to that point. We do have public transport freight statistics. We have the sectional appendix, which is not electronic. We have strategic railway plans that are in PDF files. We have rail electrification plans that seem to be stuck on a shelf somewhere, and we don't seem to have detailed freight movement information. So what are we going to do? I think one of the key points that we need to kind of pull out here is the fact that having come up with a plan, why don't we stick to it? Anyway, I know people like a nice railway locomotive, so I'm going to talk a little bit about freight traction. So having electrified everything, why is that important? So here's a Class 70, or in the words of Iggy Pop, I feel all right, 1970. So this is apparently Britain's most powerful diesel locomotive. So I've taken a lot of this from the railway infrastructure, the railway industry associations, on why we want to electrify. So on the basis of this, even though it's the most powerful diesel, it still struggles. So I was in the conversation. So we've been kind of looking at trying to do better timetable planning by better modelling. And so there's a point near Lancaster called Shap Summit. So there's a chap called Nick who was sitting there kind of going there and kind of going, oh, I've been doing this modelling, but it's giving me a really strange answer. And then we're kind of going, well, why is that? And he said, well, as it goes up there, you know, I've got this freight train, and if I look at it based on the current model, which is just based on everything's flat and it goes at line speed, this one seems to be taking like an extra 5 minutes to go over the top of Shap's. And it was like, sorry, Shap Summit. And we were like going, well, show us. And she kind of pulled up one of those diagrams, and we could just see that it was creaking. And part of the problem was actually at the bottom of the hill, it was being held. So one of the problems that you've got is that for larger freight trains, diesel traction doesn't have enough power to accelerate, so they get in the way. And where you get to the really steep bits, they're not powerful enough to run or operate at maximum line speed. So that really starts blowing away capacity and start delaying other freight trains and passenger trains. So one of the things that you need to sort out is how do you get more powerful locomotives? And here you go. The Electric 92, it's a Danger, a high voltage train. So this is a Class 92, and it is twice as powerful as the Class 70 train. So, but to make it work, you need to be in a position where everywhere that it wants to run is under the under wires. So if you want to promote modal shift and actually get the best bang for your buck, you need to start electrifying the railway. It then reduces the speed differential between freight trains and passenger trains, freeing up passenger. So here are the Class 66 revisited, a slight callback to Bob Dylan. So you will still always need diesel and freight. You've got engineering trains. There are times when stuff breaks. There's parts of the network you can't. And you can offset some of the issues you've got there with, I don't know, either carbon offset or zero carbon biofuels. The problem that you've got, though, is that's not really good enough for the core network. You may need these diesel electric bimodal trains, might be one thing. So you have diesel electric, and that deals with going in out of yards and then kind of handover and shunting works. But they're always going to be half the power effectively by weight of and the speed of a fully electric train. So again, they only kind of really work when you've got dedicated networks, freight only lines, and you're using them in freight terminals. So although people talk about, well, why can't we have bimodal trains, and they seem to be working really well in the passenger space, they don't work for freight because it's too heavy. The other thing about it, oh, sorry, I've managed to break a slide. I will fix this. Here's some figures again from this, which is about the density of fuel, as you can see. So the rail industry looked at hydrogen at different pressures, looking at batteries based on that. Their estimates, and I don't know how true this is, but their estimates is that you need 10 times as much physical storage, well, 12.5 times or 7.5 times physical storage to actually get hydrogen to work. That might again work with passenger trains. It's going to be difficult for a freight. If you're looking at batteries, it becomes even more insane. Currently, based on figures, to get a Class 66 with equivalent power, you'll need to have a 350 ton battery to get it to be equivalent. So whereas hydrogen and batteries may be useful for passengers, the smart money seems to be that it probably won't work for freight. So as we start drawing towards the end, sorry, I'm slightly overrunning. I just want to talk about a very European railway. So the European Agency for Railways has actually come up with an approach which is based around focusing on moving all freight above 500 kilometres. So they want to reduce to 50% between 500 and 1,000 kilometres, and then basically everything else off the road and onto rail. They are very heavily investing in this, and I think it's quite an important and detailed piece of work that needs to be so they're looking at combined transport and making it price efficient. So under 300 kilometres, there's an argument that road is the best way to move that. But one of the key parts about it is you could get this reduction, 90% at over 1,000 kilometres. The estimate is that you would actually give rail a 36% market share and reduce 20% the overall CO2 road transport emissions. There's then another part. So I've been kind of peripherally involved in this. So there's a group in Austria called RailNet Europe. They coordinate a lot of the overall technical change. And they're actually looking at a smarter timetable. And the smarter timetable is important because it's actually a way of starting a lot further out. So rather than that 72-week, these are months, so 60 months out, so 5 years out. Start thinking about what you're going to need to do around digging up the railway. That's the capacity restriction part on the right-hand side. So it's all about advanced planning. And publish a capacity model about what is going to be available, factoring in rolling stock changes and factoring in expected delivery of capacity. So you can actually see the changes that are coming through. So you start off with your strategy, you move to a model where you're actually putting this in so that people can see this. So it's transparent, both from what the freight operating companies, the train operating companies and others want to use, and also what's happening from the infrastructure manager side. You need to harmonise, so you need to kind of make sure that all parties, so I don't know, HS1 and Crossrail and HS2 are aware of all of what's going on here. And you also then need to do an important change. So about 18 months out, what they do is they bands. So they say, within this particular block of paths, this part of the timetable, we will actually say we're going to give 30% to freight, we're going to give 30% to passengers, and then the other 40% we're going to unallocate until, and then you start ring fencing and start thinking about the mix, and possibly you change that to a period of the day or days of the week, but you actually start planning out where you want to run paths, and you start actually offering paths as potential paths that can be called out rather than always responding to bids. So I think this is quite an interesting development that actually needs to be seriously considered. We then can talk a little bit about rail capacity in the UK. So HS2. HS2, if you do all of the phases, there's assessment that says you can get 144 freight trains. As we've already identified, there's 76 HGVs corresponding to that. And on that basis, you can actually start moving really quite large volumes of freight. But we've decided not to do part of it. And that for me is a frustration, going back to stick to the plan. Okay. We then got fixing the network. So one of the problems we've got is we've got all sorts of pinch points. We don't have long enough loops to allow stuff to pass. We have a lot of stop-start, which is highly inefficient. So what we need to do is to be able to run freight trains at a constant speed, except for when they need to load and unload. We then also need to start looking at alternative routes. So if there is engineering work, sometimes we'll only find there's only one set of gauge clearance that allows the train to run between 2 points. And so that's no freight services that weekend because it's out. So we need to improve the service recovery. So we need to be better at understanding the characteristics of train, investment in traffic management systems, and we need to look at planning more and taking freight into consideration, because also freight tends to run overnight, and that also tends to be where we do all the engineering work. So a very British approach. So freight today, what can we do? So the first thing to do, there was an interesting report looking at 20 2033 to 34 and 2044 to 43 to 44. It identifies where switching is really easy, freight is competitive and price sensitive. And that tends to be where rail suffers. But, and I think this is, again, quite a key point, if road and rail were to face the full external costs, that is, the cost of maintenance of the roads, the cost of pollution, the cost of carbon dioxide, and you actually made both parties, the VAT on fuel, if you made both parties equitable in that way, rail freight is significantly favoured. But this is a political decision about ensuring that the polluter pays, literally. There's a kind of a throwaway line in this where it kind of goes, well, one of the things we modelled, but we're not really serious about this, is why don't we build a dedicated European gauge freight link between the Channel Tunnel, the East Midlands, South Yorkshire, Manchester, Carlisle and Glasgow? And the question is, why don't we build a dedicated, but it's just like a throwaway remark in this report. If you look at the numbers, in that one step, you could actually reduce, and I know it doesn't sound that much, but it's a 1.25% reduction in the total UK CO2 emissions. And the point about this, so I think there are two things about this. So the first thing is, that seems radical. For me, though, and this could be just I've done the maths wrong, it's not that big a deal. But it kind of shows you the scale of the problem we're up against. So, in conclusion, it's about planning. It's about incremental change. We need to have significant investment in rail freight, but it will make a difference. But is it enough? So, apologies, I'm slightly over time. If people have got a few minutes, I will drop back to this and just say, has anybody got any questions? If you want to type them in, or if you just want to go off mic and just shout.
Hi, Will. Thanks for the talk. I've got two questions, if that's okay.
Of course, please shout.
The first one is, you mentioned earlier about the challenges of managing timetables across national borders.
Yep.
In terms of looking at how the UK timetables integrated with the Channel Tunnel and therefore also into the French network, is that some sort of a digital integration between the systems, or is that purely one team ringing up another team and trying to organise that? And the second question is...
sorry, can I just take it one at a time? Sorry,
yes.
I won't remember.
Okay.
So there is actually an online tool that RailNet Europe manage. So part of the reason why they're doing this particular piece of work, and there's quite some interesting stuff. And I'm sorry, I had a few more things I wanted to say about that, but I hadn't realised quite how long the talk was. I mean, hopefully it wasn't terribly boring. Anyway, so there is a tool that the RailNet Europe have as full path harmonisation. So it's not quite as bad as people shouting at each other down the phone, although that's not far from the truth often. There's actually an online tool. I think it's called PCR, that you can connect to, and a lot of that work is done in that way. I have had conversations with Eric, my friend in SNCF Reso, about trying to do a better job than that, but they're still at quite early doors. You've also got to remember that in terms of volumes, though, there aren't. One of the things you see about harmonisation of the European network is you have a kind of hub and spoke model. So Austria, Germany, France, Switzerland, trains come at them from all angles. Denmark, Norway, Britain, Portugal, you're on the end of the line. So it kind of drives a slightly different behaviour. And I think one of the things that we need to kind of consider is that. But yeah, in terms of there is a tool. It's not great. There's like 4 people who manage it on behalf of HS, HS1, and SMCF. Sorry, Eurostar. But it kind of works. Where it really comes seriously unravelled is when stuff goes wrong. But maybe I need to do a talk about operations. So Xander, does that answer that one?
Yeah, it does. Thank you. And the second question was looking at the systems. You mentioned the sort of the systems that build in towards the whole transport planning setup. And it looked to me, the way you explained, the way I understood it, is there's a lot of separate data silos where a significant majority of it isn't properly digitized, where it's very old, where there's poor integration between them. Is this a case of slowly working through and digitizing and integrating, or is it a case where we have to start from scratch with a brand new integrated modern system as a backbone to work from?
I'm going to say a bit of both, which is terrible. I mean, again, you're probably talking quite a lot about my day job. So in terms of planning systems, there is a piece of work called there's two programs of work going on in the timetabling planning space. So there's a piece of work called the Integrated Timetable Redesign Project, which is looking at trying to address the integration between access planning, timetable planning, and operations world. And it's early doors, but we are actually having some successes about building some of those interfaces. And so if you remember, there's those 16 boxes I showed. That's actually one of the that's kind of the model we're using, or the kind of process decomposition we're using to define how we're going to build those interfaces. Because a lot of it is, I mean, at the moment there are some batch file transfers, but a lot of it is email. I mean, I think in freight, to Deutsche Bahn Cargo in Doncaster, DB Cargo have 3 vans a week driving half a ton of paper that then gets scanned for path requests, which is just madness. So there is work going on there, but there are still a lot of very siloed pieces. So I mean, sorry, there's almost a whole talk about that. In terms of there is a piece of work which we've got that. There is also the timetable process reform, which is actually looking at so one of the problems we've got is the IT systems. One of the problems is the way that people work, and they've worked like this for a very long time. So we might need to kind of look at changing some of the IT, but also changing some of the ways that people work. We then also got another piece, which we could talk about some other time, which is around, so where am I going with this? So we've got those two. There's also a technology shift, which is we call it the mainframe roadmap. So part of the reason why a lot of these systems are still around is because they are pretty bulletproof, because they run on an old series of IBM technologies. And so the approach there is to look at the existing interfaces, interpose a new modern interface, migrate people onto there, and then as you want to go along, try and unpick those legacy systems. So being very old IT, you'd have a computer system that will do 15 jobs. Well, if you want to replace those 15 jobs in that one system all in one go, it becomes very difficult with an industry as large as the railway. So what you've got to try and do is unpick that in terms of the interpose a new interface, and then you pick off each of those functions one by one. There's a piece of work that's been done to scope that work out. It's quite expensive, and it's still being discussed. However, in a discussion I was in, it was described as being an important enabler for the Great British Railways. And hopefully it's something that we can actually see some movement on during Control Period 7. But also remember, this is the railways, nothing happens particularly quickly, but it gets there eventually. Sorry, so again, there's a lot to unpick there, but does that kind of cover that second one? There are plans and there's some work. It's a grind.
Brilliant, thank you, Will.
So just to close out, I'm sorry. I mean, I did slightly overrun, but you know, what can you do? It's an exciting topic. Anyway, my approach is always build it and they will come. Parting words. Thank you very much for coming along this evening. The timetable is awesome, as is Hendo's relish. The timetable is the most perfect product of the human mind. And I think that's kind of true. The challenge we've got is, unlike many other problems, railway is all about managing constraints. A lot of people are used to having almost networks with infinite capacity, and they kind of deal with that. The railway is one of those really weird things that kind of makes you think about how you do the best with limited resources and balances across the different challenges. So on this feast day of St. Vincent, let's just look at data starting with the publication and interpretation of current railway with examples from rail freight. see the challenges and think about how things could be made a little bit better. Hopefully I've done that. It was a bit nerdy. It's not every day that I get to quote Homer or the CIF file specification. Here is a rather interesting plaque I once found at one of the bases in thing. It celebrates the first 1,000 kilometers under Franz Joseph I in Austria. So, you know, it is possible to build a network if you want to. And I think what we need to do is to think about how we can build a bigger and better network. Anyway, so thank you very much.